Hello and greetings to everyone. Today we are going to treat the intersection of the line y equal to mx plus c. Remember, this is the general equation of a straight line, and the curve y equal to ax squared plus bx plus, here I'll make use of c prime so we don't get confused of the two c's. We're going to take this, consider the sketch below of the curve y equal to ax squared plus bx plus c prime. Remember, a must not be equal to 0, and y equal to mx plus c. Let's draw the sketch. This is our y-axis. This is our x-axis. And in this case, we assume that a is greater than 1. For e greater than 1. Remember, when a is greater than 1, that means we have a valid parabola. So let's draw a parabola. We have something as such. So this is the curve of y equal to ax squared plus bx plus c prime. Let's assume this is our straight line. The line y equal to mx plus c. And this is our line y equal to mx plus c. And these are the points where the line and the curve meets. They meet here. I'll just trace out the coordinates. The x and y coordinates at the point where they meet. X here. At this point, x is x1. Here, y is y1. Y here is y2. The x coordinate is x2. You will notice that the points of intersection of the line and the curve, their x coordinates and y coordinates are the same. X coordinates, y coordinates are the same. It therefore means that the point of intersection of the line and the curve, the equation of the line is equal to the equation of the curve. Ax squared plus bx plus c prime is equal to mx plus c. We take this down at the points of the section, points of intersection of the line y equal to mx plus c and the curve y equal to ax squared plus bx plus c prime. The equation of the line is equal to the equation of the curve. That's what it simply means. It therefore means that we have nx plus c to be equal to ax squared plus bx plus c prime. That's what it simply means. And next step, we are going to transfer all the terms at the left hand side to the right hand side. So this will give us 0 to be equal to ax squared plus bx minus mx plus c prime minus c, which we can write this as ax squared plus, we can factor out x here, b minus m times x plus c prime minus c as such is equal to 0, which is a quadratic equation. If we solve this quadratic equation, we are going to get two values for x, which are the two values for the x coordinate. You can see x1, x2. So after solving the quadratic equation, we are going to get x1, x2. Then we can make use of y equal to mx plus c, or y equal to ax squared plus bx plus c prime to find y1 and y2. Continue, comma, which is a quadratic equation. It is a quadratic equation. Next, we write this down by using our knowledge of the discriminants of the quadratic equation. We can be able to know whether the line cuts the curve at two distinct points, or the line does not intersect. Does not intersect the curve, or the line is a tangent. That means it touches the curve at one point, tangent to the curve. We underline this, they are very important. The line curves the curve at two distinct points, or the line does not intersect the curve, or the line is a tangent to the curve. Okay, now we take this down from this our quadratic equation. I will underline this quadratic equation, it is very important. From ax squared plus b minus m x plus c prime minus c equal to 0. We let b1 b subscript 1 to be equal to b minus m and c1 to be equal to c prime minus c. Insert them in this our equation. We're going to obtain this ax squared plus b1 x plus c1 is equal to 0, which is a quadratic equation. We go by the magic, we take I if the discriminant, which is b1 squared minus 4a c1 is greater than 0. I'll underline this, then the line intersects, means cuts the curve, intersects the curve at two distinct points. The next one, 2i, if the discriminant b1 squared minus 4a c1 is equal to 0. In this case, we are going to say that the line is a tangent to the curve. Then the line is a tangent to the curve. We move now to 3i. If the discriminant b1 squared minus 4ac is less than 0, underline this, then the line does not intersect with the curve. These are the three possible cases to know whether a line intersects a curve at two distinct points, whether the line is a tangent to the curve, or the line does not intersect with the curve. I'll just draw the three diagrams for that. We have something as such. Okay, these are the three possible cases. For this case, you see that the discriminant is greater than 0. Here the discriminant is equal to 0. And here the discriminant is less than 0. You can see the line does not intersect with the curve. Here the line is a tangent to the curve at this point. Here the line intersects the curve at two distinct points, here and here. Now let's look at some examples on this. Take example, equation goes find values of n for which line y equal to mx minus 3 is a tangent to the curve. The tangent to the curve y equal to x squared plus 1. Take solution for the line y equal to mx minus 3 to be a tangent to the curve y equal to x squared plus 1, comma, then the line y equal to mx minus 3 touches the curve, because this is the condition, touches the curve y equal to x squared plus 1 at only one point. And at the point where the line touches the curve, then the coordinates of the line and the curve, they are the same. That means at this point they are equal. That is, we are going to equate the curve to the line with the line to the curve. It is still the same thing. This gives us x squared plus 1 is equal to mx minus 3. This will give us x squared minus mx plus 1 plus 3 is equal to 0. This will simply give us x squared minus mx plus, if you take 1 plus 3 gives us 4 is equal to 0. And this is a quadratic equation. We know if the line touches the curve at one point, then the discriminant of this quadratic equation must be equal to 0. So we need to find the discriminant. We comparing x squared minus mx plus 4 equal to 0 with a x squared plus bx plus c equal to 0, or a will be 1, comma, or b will be equal to negative m, and c will be equal to 4. So we are going to insert them in this our formula, which is d squared minus 4ac, and this will give us negative m squared minus 4 times a, which is 1, times c, which is 4. So this will give us m squared minus, 4 times 1 remains 4. 4 times 4 gives us 16. So we know for the line to be a tangent to the curve, then the discriminant must be equal to 0. We are going to equate m squared minus 16 to 0. We know this is as m squared minus 4 squared is equal to 0. And this is the difference of two squares. With factorization, m minus 4 times m plus 4 is equal to 0. At this level, you are going to see either m minus 4 is equal to 0 or m plus 4 is equal to 0. If we find m here, m will simply be positive 4. Or we find m, in the next case, m will simply be equal to negative 4. So these are the two values for m. Now we can write down the equation of the line. The line might be y equal to, we take negative 4, replace m with negative 4 x minus 3. So this is the first possible equation of that straight line. Or the second possible equation of the straight line is y equal to 4x minus 3. And we are done with the solution. Now we are going to end by taking down exercises for application. Take this down, exercises for application. Question 1 says, prove that y equal to x minus 3 is a tangent to the curve, y equal to x squared minus 5x plus 6. Full stop. And find the coordinates at the point where the line touches the curve. We go now to 2. We have for each question, state working. You should carry out the solution before stating which of the following conditions apply on the straight line. To the curve. We have a tangent to the curve. So we have that's the curve at two distinct points. 3i, neither cuts nor touches the curve. The question A, we have the curve. The curve is y equal to 3x squared minus 4x minus 2, and the line is y equal to x minus 3. Question B, we have y equal to 7x times x minus 1. This is the curve, and y plus 2x plus 1 is equal to 0, the line. For C, we have y equal to 9x squared minus 3x plus 10, and y equal to 3 times x plus 3 for the line. In our next video, we are going to start by correcting the following exercises for application. You do well to go through the exercises. If in case you have any problems, you leave your questions at the comment section. Please like the video, share, and subscribe to this YouTube channel. Thank you very much for watching.